Alright, we are recording. Yep, I'm going to check something real quick on the recording. I just want to make sure I'm checking to see if there's a way to record on the phone, because I'm not sure, because it's a speaker here, I don't think it's probably picking up your voice, so it may not pick up the introduction. Let's see, audio. Give me 1 second. Okay. Thank you, Leo. We're going to start off with the basics here by doing a login. Your login ID is ordinarily set up as your first initial and last name, and you can change your password. Password is the same, first initial, last name, and you can change that from the main menu once you get into it. A few people have requested login IDs that are different than their first initial, last name. I have my own special login ID here as an admin. Once you've logged in, you'll get the main menu here, and there's configuration information you should know a little bit about. Over in configuration, there's some setup stuff under agency setup. There's not much else you can see here. You won't have administrative functions and some of the other things, but under agency setup and agency defaults are the important things that you'd want to check out. So once you select agency setup, agency defaults, and configure, it'll have the name of your agency at the top. And this is just what appears in report heading line 1 and report heading 2 at the top of every report. So if I said County of Santa Clara, I could say Public Works or Traffic Engineering or whatever title I wanted under there, and those will appear at the top of every report. You have a default city and default county, and those should be in there automatically. And then distances for intersection related, which we'll talk about in a minute, and the default query range. And these are the dates that come up on the query screen when you open the query menu by default, but you can change those dates to whatever you want. So now these are agency wide, so what will happen is if you change any of these, it changes at your agency only. So with that, we'll back out. On the main menu also is a guide under guides, and when you click it, it'll download the latest PDF guide for the system, and I think it's 40 some odd pages long, and it has some nice screenshots of everything in it. Now the main things you'd want to go through in the guide, the first 10 pages cover really just about everything you would need to know, and talks about running queries, and in particular though there are a couple of definitions that you should be aware of, and that's the intersection related definition, meaning when you say an intersection related collision, it's everything within a certain threshold distance of the intersection. We consider it 50 feet. Unless it's a rear-end collision on approach to the intersection, which case we go back 150 feet. If you want more detail on that, it is on the the analytics guide here. So, and whenever you click it, like I said, it downloads the latest version of that because we update it on a regular basis. So, all right, from the main menu, we start out with the collision queries, which is where you'll really be doing all of your work. We have queries for citations and some other things too, but this system doesn't contain citations, and the collision data on the back-end shared database doesn't have any personal information in it either. All the names, addresses, phone numbers, and vehicle license plates, things like that, have been stripped out of it. So, alright, here's our query menu for our collisions, and it's divided into three main sections. Over here in this section are the different types of queries you can run, and each of these icons or pictures has a different query that it'll run, and some of them run differently depending on what you've selected over here too, but you'll see that as we go. In this area over here are the filters that you can use to limit your queries by, and these apply to all of the queries over here except below this line where it says queries by date range only, and those are queries that only apply to the dates. Up here on the top are the dates that you're running the query for. I'm running it through 12/31/2018. I think most of you will say if your police department is providing data, it'll run through October 31st, 2018. And if it's Switter's data is the only data for your agency, it'll go through 12/31/2017. You can change these here for whatever date range you want to query on, and there's records going back through 2004 in the system. This area over here is our location-based query section. When we say non-location, it means everything we run is going to run for whatever agency you've selected. Speaking of the agency you've selected, when you log in, your login ID has an agency associated with it, and it will automatically put in an agency name here under city. Even if your agency is a county, it still says city. And it'll put in, may take a few seconds the first time you run it to put in the street model for your agency. My ID lets me pick any agency, and you can pick any agency as well if you want to see what's going on over in Palo Alto, or if you want to compare stats, certain types of stats countywide, you can do that too. So, all right, so I've got an agency in there, and we have dates up here. Location-based queries are things that are where I'm querying on something that's location-based. It's an important definition in Crossroads because just about every query, or many of the queries, like the report listings and mappings and things like that, will show you the location of the crash, but that doesn't make it a location-based query. A location-based query, you're querying for like high-incidence queries, saying show me my top 10 locations, or you're querying on a specific location, a specific intersection, or a specific corridor where you're, or mid-block segment, that's what we call it. So you're querying on a street between two limits, and those are location-based queries. If you got non-location here, if you were to run something like collision type, or better yet, I'll say involve with, I don't want to see bicycle. And so if I run this query, I've selected a filter, and over here is one of the queries, the report listing, and it's a non-location based, meaning when I run this, it's going to show me everything regardless of what location it was at. So even if the officer listed that it was in a parking lot or in a parking structure or something like that, it would show it here. So it's a non-location based query, but it does show what the location of every crash is anyway. So these are bicycle collisions for, it says County of Santa Clara, but as you saw, I picked Sunnyvale for our data. So, all right. Also, in the section here for location-based queries, we have a specific street. If you just wanted to query for all collisions on a street, or query for high incidence, meaning your top 10 or top 20, whatever number, we'll get to that in a few minutes. Mid-block historical, where do you pick a street and two limits, or an intersection, where do you pick a street and cross street. So those are the main sections of the query menu. Now, we're going to go ahead and run some of these reports here, and we're going to go through them. This will be the bulk of our presentation, talking about what these different reports do, and we'll get into detail on a few of the other ones too. So, all right, starting out, the report listing, which you just saw. It's I said bicycle, and now I'm going to change it slightly and say bicycle or pedestrian or bicycle, and I'm going to go ahead and run the report listing. The report listing is just a report that lists all the collisions sorted by date and time for whatever you've specified in the filters or the location-based specifics here. and now I've got 981 instead of the 530, I think. The report itself, you could print it just by hitting print on the menu here. You can also save it to a different format by right-clicking on it, and this is true of all of our reports, by the way. If you right-click on it and pick Output To, you can save the report in a number of formats. You could save it as a PDF, which would be the most common one, as an RTF, which is a Word document, if you wanted to include it with other pages from another document. You can save it as a text file or a variety of other image files. There's an Excel option here, but that's not a good option because each row is kind of a mess that way when it shows all these rows. So there's a better way of doing Excel. I'll show that to you in a minute as well. So, all right, on the report, it gives you the title. There'd be a second line here if you had a second line specified in the setup that we were showing under the agency defaults, and it gives you the date range that you queried for, the total number of collisions in your results, the number that are injury collisions, and the number that are fatal collisions. Now each row, each collision starts with a gray bar and gives you the report number, and if you're using Switters, by the way, on your data, if your data includes that, and many of them do for the historical data, I think everyone does, the report numbers are not the actual agency report number, but the Switters report number that they key in. Shows the date and time, day of the week, the location, distance and direction, weather conditions, lighting conditions, party number at fault, and the collision type, motor vehicle involved with, pedestrian actions, and vehicle code section violated, whether it was hit and run, highest degree of injury, number injured and number killed. And then it shows entries for the relevant data for every party. And these on this first page all have 2 parties. If there were 10 parties, it would show all 10. If there were only 1 party, it would show just the 1. And it gives us the party type, their direction of travel, and movement preceding collision, gender, age, and some other information, vehicle, year, and make as well. And then their associated factors and their safety equipment. So now you can progress through the pages using the arrows down below, and this is true of all of ours. If I go to the last page, it also shows us the settings that were used for query. There's 148 pages in this report, but at the very end, the settings used for query indicate the starting and ending dates that you're running the data, running the report on. Now that could be split, because if you have Switters data for part of it, and your police department is either providing data to LexisNexis, for example, for acquisition by insurance companies through us, then that data is data entered. Or if they're writing reports in the Crossroads report writer, then you've got police department data as well. And it will show you those split date ranges for those that are on Switters and those that are on police department data. It shows us the settings for the query. Here we said involved with pedestrian or bicycle, and we said it was the city of Sunnyvale. And also there's a notice on your system that says data is sourced from Switters, the most recent years considered provisional by Switters, and it's sorted by date and time. So that's the report listing. And let's see, if you want to do an Excel sheet on this, by the way, I mentioned that there's a better way of doing it. So if I close the report, and we give you a couple ways of closing it, you could right click on it and pick close, or use this button here. Below is a little tiny link that says open table for last query. And what this does is it opens it, but it does what we call flat filing. So it takes the query and puts every single collision on one single row, and gives you most of the information that we just saw. And so it takes a few seconds to flat file it. But the thing is, if you have every single collision on a single row, then it makes it a lot easier to copy and paste it into an Excel spreadsheet. So once that comes up, you can copy individual rows by selecting the far left blocks, or by clicking in the upper left corner, and then it could copy or highlight it all. Here's what I was talking about when you can select certain rows. Or if I click in the square up in the top, then it highlights everything. And from here I can go to the File menu and pick Copy, or I can hit Control-C on my keyboard, open an Excel spreadsheet, and hit Paste. And it gives you all the relevant information in a nicely laid out spreadsheet format. So that's the Excel part of it. Some of the other queries we can run, there are pie charts and bar charts and injury reports. We'll take a quick look at each. I'm going to go ahead and do a pie chart of, I'll take out the pedestrian and bicycle, and maybe we'll do just a little bit shorter date range. We'll say 2015 to 2018. And if I do come over here to pie charts and bar charts, those are the 2 tabs here. But on the pie charts I can say primary collision factor and collision type, and just run it by clicking the icon. And it will give us the a pie chart breaking down all primary collision factors in the city of Sunnyvale citywide for the date range that I've chosen there. It's 3.5 years essentially, because 2018 is not done. Now these pie charts, and there's 3 different ones. There's the involved with and weather and lighting conditions too. Tells us that unsafe speed citywide is the most common collision type, and then followed not far behind that is improper turning, auto right-of-way violation, right on down the list, and below the pie for collision types, with rear end being the highest one with 31%. Now this gets a little messy in here, and you can adjust that. For example, I see there's improper passing as 29 collisions. I might say, well, don't show me anything with less than 25 collisions in the minimum graph value. And so if I run it now, it'll give me the same pie chart, but everything with 25 or less than 25 collisions actually will be combined into a small pie slice called all others. So it'll be a much cleaner pie chart that way. In bar charts, we won't go through them, but there's bar charts for relevant things like primary collision factors, collision type, day of the week, month of the year, or by year as well. So that's cleaned up there. I could even clean it up more by saying don't show me anything with less than 35. And all others in this case was 0.09% of the total, only 4 collisions. So there's our pie charts and bar charts. I think you'll find those handy, and they also work with, of course, all of these queries work with all of the filters and the location based. Now somebody is typing, and so it's coming through. Maybe we could have someone either mute themselves or stop typing, because it's just a little bit noisy. So, all right, thank you. Okay, so still on Sunnyvale here. Some of the other report types, the injury report. If I just run the injury report for that 3-year date range, and once again I could pick anything else here. Maybe I want, maybe we will. Maybe we'll say for collision types that are vehicle pedestrian, I want to see the injury report for those. And so the injury report breaks down the number of total collisions, number of collisions that are injury collisions, non-injury collisions, and fatal collisions, and then the number of persons injured and persons killed, and the total number of what we call victims, or CHP terms as victims. That's anybody who's injured or killed. So in this case, 181 collisions and 182 victims in that. So, and that was it's not unusual. These numbers ordinarily wouldn't match so closely, except that we picked those that are involved with vehicle pedestrian. And at the end of the report, you can see our settings used for query, vehicle pedestrian in the city of Sunnyvale. And once again, too, you can right-click on any report and export it in different formats too. So, all right, so that's the injury report. Maybe I'll do a report where we show. Oh, let's do the day and time report. Once again, I'm on vehicle pedestrian. Now, there's sometimes more than one way to phrase something, because the collision type may be vehicle pedestrian, but I could also say involved with pedestrian, and do it that way. I could also say, give me all where one of the party types is a pedestrian. And those numbers don't always match. Note that, because just because the collision has one party that's a pedestrian doesn't mean it was a vehicle-pedestrian collision, because a vehicle can strike another vehicle, then strike a pedestrian, so one of the parties is a pedestrian, but the collision type could be rear end, broadside, sideswipe, etc. So right now I'm just going to say pedestrian or bicycle and run the time and day report. And the daytime report breaks down whatever you've limited by the filters or location based, either way, and gives you a 2-axis grid breaking down the time of day and the day of week across the bottom for all these collisions. So, and the second page will have our settings used for query, by the way. Once again, we queried for pedestrian or bicycle. Back to the first page. So for our pedestrian and bicycle collisions for that date range, we can see where they're peaking. And I've got 44 collisions on the 6 to 7 o'clock hour, and that looks like that's the most. We also peak in the morning too, not a surprise with the commute to school going on. And I can look at it by every day of the week and see what those peaks are, or by weekdays or weekends, and then the totals for the day of the week are across the bottom, so I can see which day of the week also has the most vehicle pedestrian collisions, or all collisions, or any of the other drop down lists. By the way, in this row here, the first 2 rows, these are what we call scene information that is querying on, and they apply to the whole collision. In the 3rd row, these are information about each individual party. So just know that. Alright, severity factors, types, and lighting. I'm going to run this report just straight up without a filter on it. And the severity factors, types, and lighting gives you a breakdown of all the primary collision factors. Now, we saw this in a pie chart, the collision types and the primary collision factors. The difference here between the severity factors, types, and lighting is that if there's a 0 value, for a particular collision factor, primary collision factor or cause, or a collision type, it wouldn't show up in the pie chart, but it will show up here. So if you're trying to research something and saying, well, how many collisions do we have? That, well, they seem to have values because we've recorded a large amount of data, but breaks down the broadside, head-on, hit object, etc. So all your collision types are here, and your breaks it down by those that are day versus night, highest degree of injury, and they're all represented there, and primary collision factor. So here's the 0 value here of brakes. We didn't have anybody where the cause was brakes, and that wouldn't appear in a pie chart. The second page continues with those primary collision factors, so it breaks them all down, and you can see there's several values that do have zeros, like pet or other under influence, etc. So it's a very handy report. The primary collision factor by severity breaks these down by the cause, and then for each cause the degree of injuries for those causes. So it'll sort them with the highest cause first, the highest incidence first. A lot of these queries just take a few seconds to run. Some of them can be a little bit lengthy. Alright, unsafe speed was, and we saw this in the pie chart as well, unsafe speed was the top primary collision factor for this agency in that date range with 1,146 collisions. And then it just breaks it down by the number and percent of those injuries. For example, out of 1,146, 6 of them were fatal. And right on down the list you can see these for the numbers for each of them. And they're blank where there weren't any, so wrong side of road, there were no fatals for that, for example. So, alright. And the second page for these, by the way, we often get questions on. It's the same report, but now broken down by number of persons injured, not by degree of injury. So those will be different numbers, because you'll have more persons. Like fatal injury, we have 8 people that were killed, but in the first page, we only had 6 fatal collisions. So that's why those numbers differ. They're by the number of persons that have those degrees of injury inflicted on them. So, involved with by severity. This is the similar report to the primary collision factor or cause by severity, but it breaks down involved with. And involved with are things like, obviously, involved with other motor vehicle, parked motor vehicle, pedestrian, bicyclist, fixed object, other object. Got a few other reports I won't run there, but other motor vehicle is almost always the top for the involved with, because most crashes happen with other motor vehicle. In fact, nearly 3 times what the next one down is. And then the percentage of each of the degrees of injury, and that's highest degree of injury. Second page once again has the same thing, but broken down by number of persons for each of these degrees of injury. The only reason we call it victims, by the way, is that's the CHP parlance for these stats as well. So, note that there are some other reports in here too, parties by gender, race, age, etc. And you can run those and get results for those. We won't go through every single one of them, but they're not the type of thing you'd want all the time. And we've got some other things down below here, peds at fault, bikes at fault, stuff like that too, so if you want to see those that are at fault for those items. Now, Google Earth mapping. This is something very handy. I'm going to go ahead and just Google Earth map. Well, maybe instead of all of our collisions, we'll show all DUIs for this date range. Maybe we'll go back even further, say 2012, and I'm going to go ahead and do a Google Earth map for all DUI collisions in Sunnyvale for that date range. You just punch Google Earth, and it doesn't take very long. It'll take maybe 15 or 20 seconds, and it'll launch the map. And if you have Google Earth on your computer, zoom in to, in our case, the beautiful city of Sunnyvale, or the sunny city of Sunnyvale. I'm assuming that's why they call it. There's a note on yours, by the way, that tells you that if they're not street name verified, then they're not going to map. And they are more than 95% for collisions on public roadways. But sometimes officers will use a power pole, for example, as a collision location. And it needs to match the street model, and is supposed to be reporting by street, cross street, distance, and direction on for collision reporting. So, nice thing about Google Earth is you can see where collisions are occurring relative to your city facilities. So you can see where your pedestrian and bicycle collisions are relative to your school zones, for example, or your DUI collisions are relative to your sporting and entertainment venues, things like that. So you can see where they're clustering based on versus your city facilities. You can zoom in, of course, on these. You know how Google Earth works, and on Google Earth here, you can, of course, click on any of the individual pins, and it will give you information about that collision. Just the basics. This was a single party collision, as many of the driving under influence collisions are, and gives you the street, cross street, distance and direction, date and time, cause, violation code, collision type, motor vehicle involved with, highest degree of injury, and lighting conditions, and then information about the first two parties in those two. So Google Earth's got a lot of good things it can do for you too. So we'll just go ahead and minimize that for now. Alright, let's talk about location-based queries. The location-based queries are, I had said we could do a high incidence, for example. And high incidence shows us our top 10 intersection-related collisions, or I could say mid-block high incidence as well. Or I could say top 10, top 15, top 12, top 200, whatever number you want there. And then intersection high incidence or mid-block high incidence. And if you have traffic volumes, you could rate them by collision rate. And I can go ahead and just hit the report listing. Now the report listing is going to show a different report this time. It's just not just a listing of all the collisions, it's a listing of those locations. Now I mistakenly left driving under influence on, and it's showing down here. So I'm going to go ahead and take DUI off of the filter list, and we'll show the high incidence for all collisions. So all of our location-based queries work with all of these filters and work with all of these queries in this section. It gives you a lot of flexibility. So, okay, Wolf Road at El Camino was number 2, Matilda at Ross with 37 collisions. Running down the list, there's a tie for 10th place. We just said, oh no, we said top 12. There's a tie for 12th place with 26 collisions each for these locations down here. And we can take a look at these in more detail just by going to an intersection historical query. So I've got Matilda at Ross. Maybe I want to see what's going on at Matilda at Ross. So I click the intersection tab, and I've got our street and cross street. So these are all the streets in the agency that's been selected there. It's that street model. And I start typing, it matches Ross Drive. And now these are all the streets that cross Ross. I could say Matilda. By the way, it doesn't matter whether you say Ross at Matilda or Matilda at Ross. It's the same intersection no matter what. So I'm going to run a report listing. And here's a list of all those collisions. We said there were, what was it, 32? I forget. We'll find out again here. And this gives us the report listing of all collisions that are intersection related at that intersection. By the way, we talked about the intersection related definition, but you can also, and there's 37 collisions here. That's the report listing. We've seen this report already. You know what's in it. Instead of intersection related, which is the check by default, you could also say I want to see everything within a certain distance or a certain radius. We'll look at that in a second as well. I can say collision pattern diagram and check that and run the same report listing again, and now it'll change, instead of being a report listing, to a collision pattern diagram, giving us arrows showing us the direction of travel and movement preceding collision of each of the vehicles. They're colored by degree of injury, and we can also see the collision type by the position of the arrows. So what's going on here is I've got a preponderance of collisions for the state range on the south approach that are rear-end collisions. A circle is an injury collision. No circle means it's non-injury. And this little guy here running for his life, that indicates it's a pedestrian collision. The little bicycle symbol over here is a bicycle collision. Another guy running for his life. And a little martini glass like this one here in the symbol means it's a DUI collision. So we've got a number of collisions here, a couple of broadside and some pedestrian collisions. The key for the colors, by the way, is on the second page, so you can see what the degrees of injury are. And but here it looks like the predominant collision type is rear end on the south approach. Also, under each collision or next to each one is the primary collision factor: unsafe speed, following too closely, etc. So now I've distilled out this intersection. I've got a good picture of what's happening here. I can also do a pie chart or a bar chart on this location too. Maybe I'll do a pie chart of primary collision factors. And in a matter of a few minutes, what I'll have done is look at our top locations, selected one. I'm going to go back to that top, that high incidence too, and show another thing, another breakdown there that's really handy. And now I'm going to do the pie chart at this intersection. So once again, this is intersection related at Ross and Matilda, and it's going to show us those 37 collisions breaking down. I've got all others here because I said minimum value of 25. So that puts them all into all others. So let's take that minimum graph value out and make it 1. And now we'll get a pie chart of some actual values. Once again, any of these, we could run the injury report, time of day and day of week report on this too, and really hone down specifics on what's happening at this location. So, alright, much better. So unsafe speed, 24% of the collisions, 18% are a violation of traffic signals and signs, auto right-of-way violation right on down the list, and broadside is the #1 collision type. Oddly enough, there's more broadside than rear end, because looking at the collision pattern diagram, I saw all those rear end arrows and thought, well, that's the predominant type, but it's not. So, alright. I wanted to go back to that high incidence again. By the way, there's another way of breaking this down. I can break it down by collision type or injury severity. So I'm looking at the top 12. This is the same report I just ran that showed me those top locations, but it's also going to show the number of collisions of each collision type: rear end, head-on, broadside, vehicle, pedestrian, etc. And that helps us look for patterns of collisions. So for example, at Matilda and Ross, there were 37 collisions, but 14 of them were broadside and 10 were rear end. And Wolf at El Camino Real, 42 collisions, 15 of them are rear end, etc. So this is a good place to pick up patterns of collisions to see if there's something unusual going on that you could apply your expertise to mitigate. So, all right, back to intersection. We said this was intersection related. We can also do everything within a certain distance. So if I said everything within 500 feet instead of, not 0 feet, get my 5 in there, 500 feet, maybe I'll make it 800 feet of this intersection, and I take out intersection related. Now it's going to show me, if I could just uncheck that, I could run the report listing or any of these reports as well and get all collisions now within 800 feet. And there should be more than 37 this time. We also have a radius query too, and the radius query just shows you everything within a radius of that. The nice thing about the radius query is it shows you everything regardless of whether it was referenced to, oops, I had collision pattern diagram on. That doesn't make much sense to do a collision pattern diagram within 800 feet, but we'll do the report listing. We'll have more than 37. Now the radius query is nice because it shows you everything regardless of what intersection or what location it's referenced to. When I do this, when I say a distance or an intersection related, it's going to be referenced to Ross and Matilda. But there could be other locations within whatever radius I specify that are, there's 52 collisions now, that are referenced to other locations as well. And this can be handy if you want to find everything, around a school zone, something like that. You just pick the radius and it shows you everything within that radius. I'm not going to show that. I'm going to keep moving on here. You can experiment with that on your own, just because we have a number of other items I want to get through. So, all right, I want to do a map of the bicycles, for example. So I'm going to say non-location, and we'll say involved with bicycle, and because a lot of people do a lot of bike analysis these days. So I'll say bicycle, and if I just run a report listing, we'll get the report listing. I can do a Google Earth map, pie charts and bar charts based on that too. But maybe we'll start out with a Google Earth map of our bicycle collision locations. Now we'll check it out by time and day of week. We'll look at the primary collision factor by severity as well, which is interesting with bicycles. And our little notice saying that things don't map unless it's street name verified, meaning that the streets match the street model in the collision reports. Oops, it's flashing down here. Reload it, yes. And now here are bicycle collisions for this agency. Yep, just the bicycle collisions. There's a fair number, and you can see what routes there are more dense than others. So, once again, you can click on any of these collision pins and get information about them, and they all of these will be involved with bicycle, because that's what we specified. That was a broadside collision, no primary collision factor specified for that one, and one of the parties is a bicyclist, naturally enough. So, and also with bicycles, I'm going to run the primary collision factor by severity, and there they are, breaking down the cause of all of our bicycle collisions by severity. You can do pie charts and bar charts on those too. I'm going to clear out a good way to clear this stuff out. Oh, and by the way, there's a little kind of a bug in Microsoft Access. If I check bar charts, it doesn't always come up. And if it doesn't, if you exit the menu and come back and then pick bar charts, then it will come up. So once in a while, that tab doesn't seem to work. But just know if you come back to the menu, it will work. I'm going to do these by month. So we're looking at bicycle collisions by month of the year. And I can do this at a specific location as well, but obviously September is the big month, but followed closely behind by June. Those are the bookends of the school year. So, and Each month is down below, and once again the settings used for query is at the second page of it. And you can kick these out by saying output to and save it in a different format as well. So we can break these down by hour of day. I'm going to run a day of the week as well for bicycle collisions. I would imagine during the week it's higher, and it is. Our weekends, Saturday and Sunday, are much lower, about half of what they are during the week. So, alright, we've looked at bicycle collisions. I'd like to talk a little bit about how the data is put into the system. There are three ways that data is in the system. The historical data going back to 2004 was all loaded with the SWITR's records. At the end of every month, every agency is required to send all of their collision reports for the previous month to the CHP SWITR's unit in Sacramento, where they key them into a statewide system. It's SWITR's statewide integrated traffic reporting system, and anybody can download records from that system. They don't have any personal information. You just have to log on to the iSWITR's CHP website and request an ID or username, and they'll process it and give you a username, and you can run queries on that site or download the raw data. And the raw data is in text file format, and we have a menu for importing that into Crossroads. So, and many of you were users of Crossroads well before the Countywide project, and were doing SWITR's import by saying import SWITR's and selecting the files that you'd requested from CHP. That's one way of getting them in. It's good data. They do quality data entry, and it's fairly complete. They input about 80 pieces of information, and it's the right 80 pieces of information. Another data source, and the only problem with the SWITR's really is that it's not as timely as it could be. Data for 2018 is all considered provisional, and it's not complete yet. So they're a few months behind when it comes to data entry, but it's still, like I said, very high quality data. And ordinarily you're looking for patterns of collisions that appear over a several year period. So it's great data for our purposes. But agencies, some of them, use our Crossroads report writer for writing their traffic collision reports. And those are agencies like Santa Clara County Sheriff, Sunnyvale, Santa Clara, and a few others as well. Now if they're using the Crossroads report writer, we have the system set up so it uploads those reports every night that have been approved to Crossroads, and then once a week we do an import into this back-end database. And although we do keep the date range in such a way that, for example, we have reports going into December for a lot of agencies, but we set it up so we say, well, the data is only accurate through October 31st. So once December ends, we'll indicate that the data is complete through November 30th. So because we don't know that all reports haven't been completed for November yet. So those are the police department sources. There's another source as well, and we coordinate with LexisNexis, who makes collision reports available online nationwide to insurance companies. So a fair number of agencies contract with Crossroads and LexisNexis to have the reports uploaded to LexisNexis, and they can be uploaded either by those that are written in the report writer or by scans of hard copy reports. So an agency might, like Morgan Hill does this. They write their collision reports in another system or on paper, and the records are uploaded, the reports are uploaded to LexisNexis. They do the data entry, and we have a download back into the system here. So that's a third way of getting data into the system. So there's really three ways, and that's how we try to keep data accurate and timely as well. The other advantage for the police department data, besides being timely, it's a little bit more complete, although all the personal information is stripped out of those reports. So let's see. We've done some import also for a couple of agencies. We've brought in some Excel data from an Excel file, Palo Alto, and there was one other too, I think Leo had provided us. But if they have data that they're not doing one of the other methods, they can provide more recent data in an Excel spreadsheet, and we've imported that. They're not as complete as the other reports. Now, there's also a danger when you're using multiple sources of getting duplicate reports in a system. So our system, in fact, we've just over the last couple of days cleaned out any overlapping reports, because you can have SWITR's reports for the same date range as police reports, and they have different report numbers. So when you're querying on it, we limit it saying, well, for this date range you're only querying for police department data, or maybe you're only querying for SWITR's data. And so that's how we keep it from showing duplicates. But recently we removed the duplicates in the system. We allowed duplicates prior to that because they don't key in the report number in SWITR's. they key in their own report number, so it was more difficult to determine which were duplicates. And so the way we kept it from showing duplicates was saying, well, for this specific date range that you have police department data, we're only bringing back PD data. And still there's a possibility of duplicates, because we see reports in the system where an agency may submit a report that's saying 18-0093, and then maybe LexisNexis keys it in as 18-93. And then maybe it's submitted to LexisNexis more than once and it comes back to us. So recently we've cleaned out any possible duplicates out of the system. And there's another reason we did that, and that's for a corridor query that I'm going to show you shortly as well. So that's how we prevent duplicates from the system. But we do have to check it periodically to make sure duplicates are not finding their way in, because officers find creative ways of producing reports. Even the same report can be different and can be data entered differently too by LexisNexis. So, all right. Those are the different datas. Let's see. If you Leo wanted me to mention something about working on establishing a connection, contact Crossroads. I'm not quite sure what he meant by that. I should have reviewed that first, but maybe Leo can jump in and let me know. You can check your list there and see if we can talk about that. Now, in Crossroads, one of the nice things too, in a county-wide system, it's all good and well that you're querying on your individual agencies, and that gives you a lot of power, but sometimes too there are disadvantages or things that you don't have, you can't do as an individual agency that you can do with a county-wide system. So a good example of that is shared intersections. So you might have collisions at an intersection that's shared by two agencies, and an example of that would be Santa Clara, Stevens Creek Road at Winchester. And that road is that intersection is shared by San Jose and Santa Clara. So if I were to go into Santa Clara, for example, and I pick Santa Clara, it's going to take a minute to put in the street model, and I'm going to query for all collisions in this date range at Winchester and Stevens Creek and see how many collisions I have. But the intersection, as I mentioned, is shared by San Jose, but I'm querying for just Santa Clara records here. So we'll say Winchester, and I said Stevens Creek, and now I'll just do a report listing, and it will show us the total number of reports in Santa Clara at Winchester and Stevens Creek. But because it's shared, some of the collisions that occur there are taken by the San Jose Police Department, and the city of Santa Clara wouldn't have those reports. The only ones they have are the reports that their police department has taken. So there's 15 collision reports for this date range at Winchester and Stevens Creek. Now I'm going to do something different. I'm going to take Santa Clara out of it, so we had 15 collisions, and I'm going to run the same query. So now I'm running a report listing at Winchester and Stevens Creek, but I did not limit it to Santa Clara, and we'll see how many collisions we have. This can be also true of mid-block segments. If you're running a mid-block historical query, and that mid-block segment is shared by two agencies, you can get two different results as well. So if you know you're querying on a shared agency or a shared location, you could take your agency name out of it and then run the query again. San Jose has a huge amount of data, of course, so it's going to take another minute or so to run this data. Alright, now I've got 21 collisions here. So there are more collisions, obviously, than we were led to believe if I just queried for Santa Clara. So now when we do a query like this and we say we don't include the agency, also on here we're showing the agency that is the owner of that collision. In this case I was wrong, it wasn't San Jose. Stevens Creek, I believe, belongs to the county. So this is Santa Clara County's crash here, and the county's crash here, which would have been taken by CHP instead of San Jose. Oh, there's more than that. There's San Jose as well. So we have three different jurisdictions at this particular intersection where the collision reports are being taken. But this shows the complete list of them here because I didn't select the agency. All right. So that's the another advantage of one of the advantages besides looking at county-wide trends with a variety of queries, because you can query on everything county-wide by doing a non-location based query, and I could say show us all where the collision type is vehicle pedestrian, and so for this date range I can, without the city even being in there, I can run all these queries and reports on a county-wide basis, and this includes in every agency. So this should be a fairly large number of pedestrian collisions. And we can also Google Earth map them, doing pie charts and bar charts on everything, including all incorporated cities within the county, not just the county itself. So, all right, once I have this, in fact, while this is running, I'm going to show another thing we've got too. We have a couple of new tools in here. Oh, that was pretty quick. 2,609 collisions, and 152 of them were fatals. 2,374 were injury collisions, and these are the vehicle pedestrian countywide, including every incorporated city. So, and like I said, we can map those and do injury reports and pie charts and bar charts and all these things on those as well. So, well, we've got a couple of new things in here. I want to talk about a corridor analysis, but before we do that, I'm going to talk about an area query, because that one relates to the other. So if I can do an area query, and what that means is I'm going to query on a polygon that we can draw in Google Earth. By the way, something I haven't mentioned, I forgot, is that on the menu too, you can also kick data out in GIS shapefiles, not just Google Earth KML files and KMZ files, but GIS maps. So all of these queries as well, if you run and say GIS map, it'll produce a shapefile. You give it a name and location, then you have the shapefile on the hard drive, and you can open it in whatever GIS system you're using and put whatever other layers you want on it too. So, all right, back to the over here. Maybe I want to do an area query. So an area query means I'm going to draw a polygon. So I use our polygon tool in Google Earth, and there are instructions on this too, by the way, in the on the menu itself. So over here, if I say area queries, there's a link on the bottom of it for the instructions for creating these polygons in Google Earth, which is what I'm about to do. So over in Google Earth, I'm going to shut off these pins here, and maybe I want in the beautiful city of Sunnyvale, I want to do a polygon around. Well, we're running a little bit out of time, so I'm not going to go find a school zone here. I'm just going to pretend I have a school in here, and I'll use our polygon tool, which is right here, add polygon, and you give it a name. I'm going to call it the Sunnyvale School, if I could spell, of Magic and Wine Tasting, whatever. And didn't spell it right, but there it is. And style and color, and I've got to give it a color here. When you hit style and color, you want to give that polygon a background color, so I'm just going to select something, and we can give it an opacity as well, because we don't want it completely solid. We won't be able to see underneath it, so I'm going to make it 50%. And now I've got my polygon tool. I can just start drawing. So maybe in this area here is where the Sunnyvale School of Wine and Magic exists, and I can click OK to that. So now I've got a thing here. I'm going to cut it and put it over on up in here under temporary places, because I pasted it under all those pins. Alright, so Sunnyvale School of Wine and of Magic and Wine Tasting. Now what you do here is you save it somewhere where my program can find it. So you save place as, and you can just put it anywhere where you're going to be able to navigate to it. So I've got it over here on the hard drive now, and what we do is I come in and say I want to select a polygon, and I go ahead and pick my polygon under temp files. This was I have Durban and Pretoria in here. Oddly enough, I was in South Africa demonstrating our software recently. And what this does is it's going to put it in a location where now it will always come up on this menu when you say area queries, and everybody in your agency will be able to see it. So I'm querying for all collisions that are within this polygon that I drew called the Sunnyvale School of Magic and Wine Tasting. And I can run any of these reports on it. I'm just going to do a Google Earth map of all collisions in the state range. But you can run any of these reports, pie charts, bar charts, report listings, injury reports, just of those that are in that polygon. So the idea here is you'd be drawing polygons for things like your school zones and sporting and entertainment venues, and as we'll see in a minute, corridors. And then you could query for just those in those school zones. And you could even name the schools, saying show me all collisions that are at the Pretoria Elementary School, for example. So now it's going to it says finish creating map. Oops. Back to Google Earth here. Oops, that's not Google Earth, that's Chrome. Alright, reload it, yes. So it's zoomed in on the Sunnyvale School of Magic and Wine Tasting and shows us all collisions that are in this this particular polygon. And you can do multiple polygons too, and select them all. So I could have selected the the Durban and the Pretoria ones too, and we could go to South Africa. Once again, you can click on these pins and get information about them too. So that's the area query, and that can be very handy. We also discovered something else. Leo thought of this too, that we could use it for, and that's that if you're doing a query on a corridor, the street model only shows the street model for each individual agency. So you'd only be able to query on a mid-block segment along a corridor that was within the agency and choose cross streets along the corridor or mid-block segment for Sunnyvale in our example here. But if your corridor wanted to extend across multiple agencies, then there's no way of doing that in the street model. But what we figured out was you could actually draw a polygon for a roadway. So what I did before our meeting here was I drew a polygon along Stevens Creek Boulevard. And Stevens Creek Boulevard, I went across Cupertino and across, I think, Santa Clara, and then into a little section of the county. And I drew it from Wolf Road over to Bascom. And so there's just a polygon that I drew, and I named it Stevens Creek Corridor. So now I've got a polygon in this segment here, and I can come in and do a query on purely that corridor. Now I saved it and brought it up in here, so it says Stevens Creek Corridor. I'll take off the Sunnyvale one, and now I can see all collisions agency-wide. I haven't selected an agency here between this date range that are in this corridor. And to illustrate the point, we'll do the Google Earth map of it and show all of them along that corridor. Now if I wanted, if you draw your corridor a little bit too wide, then you could capture surrounding intersections. So you could actually go to the street tab over here and just say I just want Stevens Creek Boulevard, and you'd show just those that are on Stevens Creek, or Stevens Creek is a crossroad with a distance of 0, meaning it has to be on Stevens Creek or in order for it to qualify. Alright, so I'm running this, and our polygon queries can take a number of seconds. Well, probably won't take a full minute. Although if you draw very complex shapes, it could take longer as well. Because math. Now after this comes up, there's one final query I'm going to run. It's a new feature in the system that none of you probably have yet, but we're going to be distributing it over the next week, although vacation's coming up or Christmas holidays coming up, so a lot of people won't be around. But we'll be updating everyone's system with this density query. And maybe I'll describe the density query while this is running. The density query gives you your top, whatever number you want, but by default it's 3, your top 3 density squares in your agency based on number of collisions, and you can adjust the size of the square. So by default it's 1 mile square, or 1 square mile. You could put in 1,000 feet instead of 5,280 for the length of the side and get 10,000 foot squares, and it will go through and do check windows every few feet, examining the entire agency and picking out the top X number of I maybe should do a shorter date range with this, but the top X number of top 10 or top whatever density squares, and it will open it in Google Earth. And I've actually, and you know what, while this is running, I can actually show that because I ran it earlier. Oh, that's done already. Okay. Of course, when I go to do something else, it says, oh, now I'm done. Now I'm ready. Okay. And it's asking us if we want to reload, because we already had something called pin 1 here, so that's its default. And now it shows all those pins purely along that corridor. So I chose a fairly busy corridor. So that's another great use for the density query. Now, or the polygon query. Now that area density query, when you bring up this map, rather this menu on the density query right here, you get a pop-up, and it says top locations 3, and then the window length 5,280, so they're 1 square mile squares, and the minimum per square, that won't be an issue for you guys, but on rural counties it could be. And you just hit run query, and what that will do is it will it'll run that and launch it in Google Earth. And I happen to have it here, the density areas. We'll just click on them. I ran it for Sunnyvale. It really only takes a couple of minutes to run, so it runs pretty quickly. But if I go to the zoom into it, this shows us the top density squares. That one there is the Sunnyvale School of Wine, Tasting, and Magic. So let's just turn that one off. I happen to have drawn that over right next to the high density ones. But there's our 3 top squares in the city of Sunnyvale. And like I said, we can adjust those squares, those 1 square mile locations. And it's gone through the entire city, looking at very thoroughly at every single area, and it doesn't just move from one square a mile over to the next square. It moves it over a few feet at a time, examining the entire city for what the top locations are. And there's our area density query, and this can be handy for other types of enforcement or traffic engineering. For example, if you're looking for trying to do traffic calming in a certain area, not just on a certain roadway, you could take a look and see what the density is in these two. And for police departments, it's great for, I think, for helping to deploy your limited resources in patrol. So you can patrol different areas and see where your top density is in collisions. So, all right, well, that covers everything that was in our outline and everything we wanted to talk about today in training. As you have questions, Crossroads is here to support the system, and we do the data updates in conjunction with Santa Clara County. And we're adding more SWITers every year, and also we do the ongoing data input from agencies that are using our system. If your police department's not using our system for the report writer, they're welcome to have that program. And so if you have a contact there and would like them to recommend start using it, that gives you more timely, more complete data as well if they're actually written in the system too. We have a brand new report writer over the last couple of months that's really complete, and it's one of the best things we've ever written. So, all right, I want to say thank you very much. I should check the see if there's questions. Someone did have a question here, so maybe I'll get to that. Sorry about that. Someone wants to highlight a collision on a polygon without including the freeway collisions. Without including freeway collisions is well, they wouldn't include the freeway collision if your agency doesn't have isn't the state. So the ones that are on the freeways do not include those anyway. So when you see a highlight one, I can and all the queries I've been doing, most of them have been Sunnyvale, so they haven't been on the freeway itself. So, but to highlight a collision, I'm not sure you meant by highlight, but just clicking on it gives you that information there. So, all right, when they somebody's saying for Palo Alto the numbers are different when you filter city. Follow up with me later at Palo Alto, because I've just replaced all the collisions in Palo Alto with SWITers. We had a number of collisions that came in from an Excel sheet, and then we had others that were SWITers. So it was kind of a bad mix, but it was all we had because we didn't have the more recent stuff. But I've just updated Palo Alto through the most recent well into 2018 with the SWITers, and we'll be putting that up there this Friday. So do a query in Palo Alto next week, and you'll see it says it's different when you query for city, 0 results. You should have them now, so you won't see that. All right. What version of Crossroads is available? The most recent version is 12.15, I think. I have to. What is it here? It's not on. I'm not showing the most recent version, by the way, as I query this. But the most recent version. Let me just check for you. And you're all obviously welcome to the most recent version of Crossroads. We'd like to keep you guys updated. I'm checking the most recent version now. Most recent version of Crossroads is I'm still on the one I'm showing online there. I think it's 12.15 is the most recent version. And just give us shoot us an email. We'd be glad to update you to the latest version. So, all right, I think those are all the questions I've got on there. Sorry I didn't answer that one about Sunnyvale on a non-freeway very well. So you can give us a call or shoot me an email, and I'll be glad to go through that with you. So, all right, Leo, I'll pass it back to you now that we're wrapping up. I'd like to say thank you for everyone. Thanks, everyone.